All right, homework tonight is just to do one piecewise function, which is a new thing. Notice we've got this f of x equals big bracket, and we've got 1, 2, 3 things happening here. So a piecewise function is one or more functions graphed on the same graph. Now, what are the kinds of functions we might be asked to graph? Notice that this bottom function has a squared, so we should hopefully recognize that that one is going to be a parabola, and that in this vertex form, we can see that the stretch is 1. So it's going to be an upwards graph, stretch of the parent stretch. And we can see the vertex right here, HK. The vertex is going to be 4, 2. So I'm looking at that parabola function, and I'm starting to see what that's going to look like. There's going to be a U-shaped graph at the end of my piecewise. Well, what the heck is just a plane 4? A 4 is a constant. That means that this is going to be the graph of a horizontal line only through 4. That's it, just literally a horizontal line. And then the upper one has the exact same format as the parabola, except there's no squared. So what kind of graph is that? Do we remember that one? Well, that's a linear, back from Math 1, where I can still pull this point out. It's not an H, a K, it's an actual X1, Y1, but this is going to be a linear with the point 3, 4. That's called the critical point, X1, Y1, and it's got a slope right here of -2. So you know this old formula, mx minus x1 plus y1, that was the linear equation of point slope form. Don't worry, we'll review that if you're like, I have no idea what's going on there. So let's go put this onto the graph. First, I'm going to have a linear with a negative slope going down. Then I'm going to have a flat horizontal line. Then I'm going to have a curve. So let's go take a peek. Starting first at the point 3, 4. I'm going to go out 3 and up 1, 2, 3, 4. And this is going to go from negative infinity up to 3. So if I highlight, this is going from negative infinity up to 3. That's going to be the section of the graph that has that line. So how do I count a slope of -2, but I can't go to the right anymore because my domain stops right here? So I need to count down and over the other direction. So I'm going to count from right here. I'm going to go, see how this would be a down 2 over 1? Down 2 over 1. My graph, my downwards graph, is actually going to be looking like that. There's my linear function going through the point 3, 4, and with a down 2 over 1 slope. Next is my little horizontal piece that goes through 4 from 3 to 4. That's it. That's my little horizontal piece from 3 to 4. And then finally, I've got my hook from 4 to infinity. This is going to start at 4, 2. And from 4, 2, we want to count the parent stretch of out 1, up 1, out 2, up 4, out 3, up 9. Okay, notice that this right here does not have an equal to bar. So that means that this dot is open or not included. So I'm going to go down here and change this beginning dot to an open dot. Oops, not a very good open dot. And then I'm going to connect my parabola, which is essentially like a hook. It's like half a parabola because that's where the domain started. This domain was from negative infinity to 3. It's already marked on the graph right here. This domain only went from 3 to 4, so that little tiny piece of the graph. And the last domain goes from 4 to infinity on this part of the graph. Now let's go look at the dot here. Oh, this should be an open dot here as well for this little horizontal piece. This needs to be an open dot. And This needs to be an open dot. We'll talk about the dots, but there it is. There's my piecewise function. This is function number 1, the linear. This is function number 2, the constant, the plane 4. And this is function number 3, the parabola. We have to recognize all the different types of graphs that might come up on this piecewise function. That's your one problem for homework. It's done.